On page 39 of your book, we are making the piece, the anchor piece for angle relationships. And mine printed in color, but I printed yours in plain white because I think you will benefit from some colored pencils in this one. So I would recommend that you stop this video and get you some colored pencils. Just 2 or 3 colors will be helpful because you'll see why in just a minute. So yours is not in color, but they should stack up the way these do. So I'm going to start with the first one, which is complementary. Complementary angles, and let me just do it this way. I'm going to bring this one over and enlarge it so that I can do some writing on it, and then I'll shrink it back down. I can't fit them all on this page unless I do it this way. So here's the thing about complementary angles. Complements, and this is a different spelling than the complement. If you tell someone they look nice, that's a different spelling of compliment. This is a mathematical spelling. Complement. Complementary angles add up to 90 degrees. So let's do an example. I'm just going to make one up. Go ahead and with the pencil, let's draw in a ray right here. So I'm going to bring in another ray right there, and we'll make an arrow to make the ray complete. All right, let's suppose that I use a protractor and I measure the angle. So with a colored pencil, I'm going to use red. I'm going to color in this part of the angle. That box, by the way, tells you that it's a 90-degree angle. So we're working with a 90-degree angle total. And then on this other little piece, let's put in a different color. So the green angle, maybe let's name this. Let's say that this is 1 point. Here's the vertex of the angle. Here's another point. So this is A, B, C. So angle ABC, that's the green one, measures, let's say 30 degrees. So this green angle right in there is 30 degrees. So that means, let's give this one a name, that angle CBD measures what? Well, if the two together add up to 90, 90 minus 30 is 60. So we would say that 30 degrees is the complement of 60 degrees. Or 60 degrees is the complement of 30. It simply means that the two of them together make the 90. When I was in school, I needed to remember this, so I remembered that complement goes with corner. They both start with a C. Complementary angles. Okay, let me shrink this thing down. I hope it will shrink together, and it did. Thank goodness. I'll move it back over in line, and we'll pull up the next one, which is supplementary angles. Let me pull it over here in the workspace where you can see it. Supplementary angles don't add up to 90. Supplements add up to 180. And I already sectioned this one off for you. But let's use colored pencils and fill this in. You'll see why in just a minute. I remembered that supplements make straight lines, straight angles, 180, and those both start with S. Okay, so I'm going to zoom in here. Now these are not 90-degree angles, so we don't use the box. Let's put in an angle right there. And let's let the vertex be point V for vertex. And let's call this one AVB. And that is this dimension right in here. And maybe that one is 50 degrees. I'm just guessing. So angle A, you want the vertex to be in the middle when you write your letters, because it has to pass through that middle point. So angle AVB is worth 50 degrees. So let's make this be point C, and let's draw it in and color it in. By the way, these are adjacent angles because they share that side. And this one is going to be what? If it's the supplement of 50, angle AVC is 180 minus 50. That's 130 degrees. If you forget the dimensions, think of it this way. If that's a complete circle, we're looking at half of it. A circle has 360 degrees. We're looking at half of the circle. So 50 degrees is the supplement of 130. Or 130 is the supplement of 50. So if the test were to ask you to find the supplement of 50 degrees, you would say 180 minus 50. Those are supplementary angles. So the next one asks us to look at adjacent angles. And this is why I wanted you to use colored pencils. There's a nice little pattern that will help you with adjacent angles. Okay, I really need to zoom on this one. I want you to put a point right here in this vertex. We're not going to name it, but let's put it in there. And let's name some angles. Let's just call this one angle A, angle B, angle C, and angle D. Now, would you agree with me that those four angles add up to 360 because it's a full circle? With a colored pencil, let's color angle A. I'm using green. And C, the same color. Those are not adjacent. Those are opposite, and we'll get to that in a minute. Color B with a different color. I'm using red. And you can tell by coloring it that it's an obtuse angle. It's very large. Color D with the same color. Adjacent angles are not the same color. Adjacent angles are side by side. So for example, A and B are adjacent. Angle A is adjacent. adjoining to angle B. Angle C is adjacent to angle D. Angle A is adjacent to angle D. So you could say that angle A is adjacent to angle B and angle D. Okay? The thing I want you to notice here is that they're different colors. They're not the same value. So what if I tell you that angle A is 40 degrees? That means angle C is 40 degrees. They make a bow tie. And those bow ties they're equal. What would angle B be? How would you find angle B? Well, if it's adjacent to angle A on a straight line, it would be 180 degrees minus angle A, which is 40. So this would be 140 degrees. Angle A and B are adjacent. They're supplementary, and so that helps us to calculate the degrees. If angle B is 140, it forms a bow tie with angle D. That is also 140. And if you add up the 140 and the 140 and the 40 and the 40, we better get 360. That's the full circle. Adjacent angles are not the same color. They share a side. Okay. So let's look at vertical angles, I believe is the next one. I should have put vertical first. That would have helped a little bit, I think. But, okay, so here we have vertical angles. You really already have seen the theory of this one, but let's do it again just to really nail that concept home. So here is the ones we're working with. Again, I'm going to go ahead and color them. The other part of that bow tie is over here. And I like that vertex because that makes the knot in the bow tie. So those two angles, we need to give them some names. I'm going to call this one M and this one N. So I would say that angle M is vertical to angle N. It's across from it. It's opposite. That's another way to say it. And that writing is thick because I'm zoomed in so far. That's as small as I can make it. So let's put A and B up here and make them red. This is a different bow tie. The vertical angles are in the same bow tie. So when I think of vertical angles, to me that just looks like a bow tie. So A is vertical or opposite to angle B. And here's what you need to know. Vertical angles are always equal. So if A is 155, that means B is, because they're in the same bow tie. So how would we find angle M or angle N? Well, we would say 180 minus 155 is what, 35? No, 25. 180 minus 155 is 25. So this is definitely not to scale, but it's okay. We can. So if M is 25 degrees, that means N is 25. And if you add up 155 plus 155 plus 25 plus 25, you should always get the 360 degrees that is in that circle. So once you know that one, let's do one more. We have linear pairs, and I'm just going to do this one right here. I'm going to try to enlarge it so I can well, I lost connect. Okay, here we go. Let's take a look at this one. First thing I want to point out to you is that we have some parallel lines. And let's give them some names. We'll call this one A and B. So we could say that line A is parallel to line B. And then this line that's cutting across, maybe this is an interstate and you have a lane or a road that's cutting across it. This line is called the transversal line. Trans means across, verse means to travel. So it's traveling across the parallels. And when that happens, look what we have. We have some linear pairs. So this one is going to be green for me. And I'm going to say that that's worth about 50 degrees. I'm just guessing, but that's 50 and that's 50. And then the other part of this, 180 minus 50, we know that this is obtuse, so that would be 130, and this would be 130. And if you add those up, you should get 360. And here's the cool thing. Once you know that one, you know this one. I'm not even going to color it. We'll just bring it down. 130 and 130. 50 and 50. Because those lines are parallel, anywhere along that transversal that we get an intersection like that, it's going to match all the way down. So once you know one of these, you know all of the linear pairs or linear triples. You could have these circles all over the place if you add more lines. Point being is that once you get one of them, you know all of them, and that each one of those circles would add up to 360.